Alright, ladies and gentlemen, this is our second presentation for unit number 6. So let's make sure that we have our notebook set up and we have a highlighter because we always take notes with our highlighter. Alright, so this week what we're going to be talking about is the engineering design process. So what is the whole process that engineers go through? And no matter what type of engineer someone becomes, whether they're chemical, mechanical, whatever, they go through basically the same type of process in order to get the ultimate goal that they want to create. So let's get going on this. So the first thing is there are 6 steps to the engineering design process. All right. So the first step is identify the problem. So what is it that we need to do? All right. Second thing is we brainstorm ideas. Right. Come up with a bunch of ideas that we think could work. And then third step is we select a solution and a plan. All right. So we look through all the brainstorming ideas. We figure out what we want to do, and then we go with that. And then we will create and build. And the first thing, and we'll talk a little bit more about this, is creating a prototype. Right. And then we're going to test that prototype to see how well it works. And then the last thing is we are going to improve it, and we are going to redesign it, because usually the first time that we make something, it's probably not the best, so we usually redesign it over and over and over again. Okay, so those are 6 steps, and we're going to go into specifics of each step right now. All right, so the first thing is identifying the problem. Right now, usually in an engineering process, as an engineer, we get the job. All right, and usually the job comes from a client or a boss, or for me, for this example, a teacher. Right, I'm going to ask you to do something, right? And you have to figure out what that is, all right? And what you do is, when you're identifying the problem, we always identify what's called the criteria and the constraints for the objects, right? And basically what that means is, what are the rules for this project that we're going to do, right? Because in any job that we have, there's always rules, right? And you have to abide by those rules to create the item that you're going to make. All right, so what is a criterion constraint? Let's go into a little bit more about that. So first thing is, what is a criteria? All right, a criteria is the requirements of the project. This is what you must do. Right? So for example, right, if I'm building a bridge and my boss comes up to me and says the bridge must be 2 miles long. I don't want it any shorter. I don't want any longer. I want it exactly 2 miles. Right? That is a requirement. So if I come back and make a plan and it's 1.5 miles, it's going to get rejected, and they're basically going to probably fire me, because they're going to sit there and go, the requirement was for me to create something that was going to be 2 miles long. What is that going to look like? All right? This is a must. Right? Now, what is a constraint? All right? This is what every engineer hates, and I'm sure all of you guys hate it, because based on just watching you guys do the spaghetti and tape structure, you guys all hated the fact that you only got 100 centimeters of tape. I'm sure all of you guys, if you guys had more tape, you would probably say we could have done so much better. All right, but in any job, you're going to get constraints or limitations, all right, to the project. So let's go back to the bridge example. All right, so criteria was, again, a requirement. It must be 2 miles. So constraint is a bridge must cost less than $20 million. So that's my limitation. I only have certain amounts of money to work with. So I have to figure out how to make a bridge 2 miles long, but at the same time, it can only cost me $20 million. Right? So that's a constraint. And the biggest constraint that most companies have is about money. Right? It's always about trying to make it as cheap as possible, because ultimately, right, in order, to make money, you don't want to spend too much money doing that. So it's really important, and that's the biggest constraint. Now, the biggest constraint you're going to have in the projects that we do is the amount of materials you're going to get. Okay? So, you could think of that as money, because money buys materials, and you only have a certain amount of materials. That's the biggest constraint. All right? So now, once we identify the problem, we can now brainstorm ideas, because now we're going to brainstorm ideas that fit within the criterion constraints. Right? And this is where having a group is huge, and that's the reason why we always do a lot of group projects. Right? So when you brainstorm ideas, it's important that everybody shares their thoughts. Right now, for you guys, going on the internet, doing all those ideas is a great place to do research. So this is where you would do research. You start brainstorming ideas and coming up with things that you think might work, all right, as you get going through. And again, biggest thing, all ideas that you come up with must fit the criteria and the constraints of the project. Okay, you can't just go off the whim and start making stuff. All right. For example, when you guys had to do the spaghetti and the tape one to make the structure, you only got 30 pieces of spaghetti and 100 centimeters of tape. You can't think of ideas that uses more than that because you don't have that material. Right. So once you decide on once you come up with a bunch of ideas, and hopefully you come up with like 5 or 6 different ideas, because you don't want to just go with just one. And this is where a lot of you guys on the spaghetti ones made a huge mistake. Like a lot of you guys came up, got your spaghetti, and then asked me for tape already. So you didn't even think about what you wanted to build. You guys just went, we'll just wing it. All right? No engineer will go out there and wing it because they know that nothing good is going to come out of winging it. All right? What I liked seeing was some of you guys, some of the groups actually went in there, instead of getting the tape right away, not even getting the spaghetti right away, you guys actually looked on the computer, started researching ideas, and thinking of what you need to do. I even saw groups drawing it out first, which was huge. All right, instead of just trying to go, we'll just start putting sticks together. Okay, and this is the part where you actually start doing your drawings. And when you select the solution, you start planning it out. All right, you don't want to just start doing it off your head, especially if you have a group of 4 people or 3 people or whatever, because you want to make sure that every single person in your group can visualize what's actually being built. All right, so what we're going to do is we're going to create what's called an engineering drawing. And this is kind of an example of what an engineering drawing is. But basically what you're doing is you're making a drawing on paper to show exactly what that item is going to look like. And you're going to draw multiple views. So for example, this one says top, front, right, side, right, another front view, and so on. Right, so let's go over just more engineering drawings. All right, what is an engineering drawing? All right, it's basically a detailed drawing of what you want to make. Okay, so these are the sides or the views that you want to include in all of your drawings. All right, so look at this shoe right here, right? They'll have all these different views. So like here's like the bottom view of the shoe, here's the side view, here's the front view, here's the back view, right? They have all these different things. I think this is like the inside of the shoe view, and so on. So they, in order to make a simple thing as a shoe, they make all these drawings so that way whoever is going to actually build it has the plans for it, right? Ultimately, what it is it's the instruction from the engineer to the person who's going to build it. Because really, most of the times, engineers don't mass build stuff, right? What they'll do is an engineer will make the plans, they'll make what's called a prototype. So one thing, and they'll test that one thing, and once they figure out that it works, then they just give these plans to their manufacturer, the person who's going to make it. So it's got to be really, really important that it's very, very detailed. That's the reason why just a simple thing as a shoe, it's very detailed. You'll notice that it has a lot of dimensions. I know you can't read that, but it does have all that stuff. Okay, so now let's talk about how to make it. And we'll practice this tomorrow, how to make one of these things. All right, but what you first need to know how to do is scale stuff, because what you're going to be making usually doesn't fit on a piece of paper, right? The drawing. For example, if I'm making a house and I put it on a piece of paper, there's no way that I'm going to make a life-size picture of a house. So what I need to do is I need to shrink or enlarge the picture based on what I'm making. All right. So for example, if I'm drawing a house, I'm going to shrink it down. So if my house is going to be, 50 feet long, I'm not going to have a 50-foot piece of paper. I'm going to probably have like maybe a 3-foot piece of paper that I'm going to shrink down. So I might have to measure it and then divide by so much to fit it all into one piece of paper. And ultimately, I want to have all the different sides showing on this piece of paper. Okay, so that's what scaling is going to be. And you're probably going to have to do that for some of them. Some of them because of the projects that we do, you might be able to draw it life size because you'll have a big enough piece of paper to do that. Okay. All right. So now how do you scale an engineering drawing? First thing you're going to do is you're going to take the original item and you're going to measure all the dimensions of the object. Okay. And then you're going to decide on a scale. So in other words, how much do you want to enlarge in or shrink down the picture? All right, or the item, I'm sorry. Okay, so if I have a house and I only have a 3-foot piece of paper, I might go, okay, I'm going to shrink it down 50 times. So I'm going to make it 50 times smaller on my piece of paper. All right, so once you figure out what your scale is, you're going to multiply or divide. So you're going to multiply if you're going to scale up. In other words, you're going to take a small object and make it bigger on the piece of paper. If you're going to shrink, right, so this would be to, this is to enlarge in, oops, to make the object larger than what it actually is, right? And then you're going to divide to what's called scale down. In other words, this is where you shrink. So this is what I would do for a house. Okay? Like something like enlarging, maybe something like a little nail or something like that. All right? So what I would do is on a piece of paper, I would write 1 centimeter equals 3 centimeters or something like that to show what my scale is. All right? So that way when a planner reads it, they know, okay, this person enlarged it by 3 centimeters 3 times or shrunk it 3 times. All right? And then you're going to draw the new thing on there. And again, we're going to practice this tomorrow. So like I just want you to write down the notes of how to do it right now. But tomorrow I'm going to show you how to actually make an engineering drawing. Okay? All right. So now once we create our plan or our solution to something, we now will create something. All right? And we're going to create what's called a prototype. This is what all engineers make. Because what we need to do first is, as an engineer, is you need to make an item before you actually go, okay, it's ready to go. For example, right, an iPhone. One of the things that they were looking at before they were going from iPhone 3 to an iPhone 4. Now, I know there's an iPhone 5 out now, but what they were thinking about doing, because one of the things that a lot of people were saying about the iPhone 3 was it was really hard to type, right? They said that maybe we need to have actual buttons instead of like trying to press a screen. So they were thinking of doing a flip, not a flip, but like a sliding phone where like the keyboard would come out. And they really thought about it. They made a prototype of this. What they later learned when they made the prototype, and they probably made like 30 or 40, and they had their Apple people play around with it, use it. What they found out that was that people didn't like it. They thought that one of the things that made iPhone really great was everything was all touchscreen. And you got away from that. And the other thing too that they noticed is it broke easier by using this, because the whole sliding thing didn't work very well. So they went in there and said, okay, it doesn't work very well. We're going to make sure that we change it up. We're going to keep it just a touch screen. All right? All right, so once you build it, now you have to test it. And this is what I was talking about with the iPhone. Once they built that phone, they had to test it. And they looked at, okay, how good is it? How are their weaknesses? All right, these are the things that you should look at. So when you test your prototypes, you should be looking at, what are my weaknesses? Okay, where did I make my mistakes? All right, what are the strengths of it? All right, because again, even though some of you guys tested your, or maybe have not tested your spaghetti structures, you should have noticed that, hey, there's some things about it that I did a good job on, and some things I did a terrible job on. Okay, and this is the most important thing, the testing part, because this is the part where you learn the most. Because this is where you start going, oh, I found my weakness. I need to make that weakness stronger. All right? And then the last step is then to improve it and redesign it. All right? We never stop after one build. You always want to build something, see how it works, and then figure out if there's anything bad or good about it, and then you redesign it. Okay? I mean, what would you do if, like, or what would Apple be if they didn't keep redesigning their iPods and they didn't keep redesigning their iPhones, right? Ultimately, people would be like, well, they're not making it any better, so I'm not going to buy that product. All right, same thing like cars, right? Every couple years, car companies redesign theirs, right? Why? Because maybe they think that it works better to look like this. Like this is, right, the old Corvette. Here's the new Corvette, right? So it's obviously very different from the older version to the newer version because there's new technology and so on and so forth. Okay? So, and I want to highlight this part. It is very rare that the first prototype works well. It usually fails, and that's the truth. It usually doesn't do a very good job, or at least the job that they wanted it to do. So they have to do it over and over and over again. All right, and that is the end of our notes. So let's make sure that you do the summary.